Today I'll be talking about lakes and how they can increase the efficacy at which you do machine learning in your organization. I'm a senior research scientist at a company called SoundTrack, and if you haven't heard of us before, you've definitely used our service. If you've ever been at McDonald's standing in line waiting for your burger, or enjoying your burger after a nice night out, the music that you hear while you're in the store is provided for by our service. So we are a music streaming service targeted at businesses. And if you haven't been to McDonald's in the past few years, we have a lot of customers around the world. We are live in more than 40 countries. And the reason why brands really like to work with us and we like working with brands is because we understand that music is a part of a brand's identity. So it's just as important as their logo, as the colors they use, as the decor in their environment when you enter their stores. So McDonald's, for example, describe themselves as human and inclusive. So let's hear what that sounds like. Oh, sorry. There we go. Right, and maybe Joe and the Juice has a little bit more expressive take on their brand, a little bit more provocative. So, right, another thing brands are usually interested in is playing explicit or non-explicit music. So if you're a family-friendly restaurant, you really don't want any racial slurs out there, anything of the sort. If you if you have a little bit more mature audience, you can tolerate certain types of explicit, and it really varies from country to country what is tolerated and what is not, even maybe in different parts within the same country. So what we do is we help these brands using AI find the best music to play in their stores that expresses their message. And we do this with by helping them search through the world's largest background music catalog. Right, so this is the first company I wanted to touch on. We are a medium-sized company, roughly a bit over 100 people. We still like to call ourselves a startup. We have enough data that is very interesting, but it's not huge amounts of data that it would be mind-bogglingly hard to work with. And speaking of large data, I want to talk about this second company, so Meltwater. They are a media monitoring company. They crawl the news from all over the world in 17 different languages. They have NLP pipelines that crunch it, do things like sentiment analysis, produce insights for their customers. And recently they had this project called Fair Hair AI, which I was very lucky to work on the knowledge graph component. And we built the world's largest knowledge graph about companies. And the really nice thing is that this is available now if you're a company that is interested in this, or if you're a research organization, you can contact them, and their vision is to enable companies and research organizations to build on top of their data. Right, and it's a very large company, multinational across the world, with lots and lots of data. Finally, a very small company, less than 20 people. I was honored to work on breast cancer research. At this company, we tried to create a computer-aided diagnosis system that is a cheap alternative to the commercially available ones from the US and Europe, because they usually cost hundreds of thousands of dollars, and radiology labs aren't able to pay that in the Middle East. Right. So the thing is that regardless of the size of your company, regardless of what you're trying to do, you always have several data sources. It can be every single news outlet on the planet. It can be lots of music, metadata. It can be lots of medical images coming in from many sources. Obviously, you want to do machine learning. NLP, audio analysis, image processing. You want to, you care about scalability, and scalability is not just about, being able to run big models. It's actually about removing the manual parts of your process in what you do. So you really care about making your process automated and effective and efficient so that you can repeat it and rinse and repeat all the time. You also care very much about data provenance and data governance in the light of GDPR, and also you have restrictions maybe on your content. You can't play certain music in certain countries, or you can't show articles in certain places, or you're not able, or if you're a medical company, you really need to pay attention to how your data is stored. So as a community, the best answer we've had so far has been data lakes, right? It's the best thing we know, and data lakes are simply just a data reservoir where you bring in all your data whatsoever, however that data is and what it contains. It can be structured, can be unstructured. It's a place for people for scientists and researchers and engineers to try and extract useful information and make that available to the rest of the organization. And the evolution of data lakes came originally a bit from data warehouses. People were kind of stuck down in this data warehouses where they had these very rigid document models that you cannot evolve over time. It's very hard to deal with, and you can't. It really slows you down. So data lakes were an answer to that. Just bring in all the data. It doesn't matter how structured it is. You can also have support for things you cannot have in the warehouse, things like audio, text, large amounts of text and video, and so on. And one of the common things that people tend to say is that, well, a lake is just a staging area for a data warehouse, right? You just bring in all this data, it's messy, and then you just try to build warehouses out of it. But that's also, like, in a way, that's really missing another important point of data lakes, which is it's an environment for all your machine learning and AI to happen. Right? This is where you really develop your data. This is where you actually work on your data. And more common than not, you fall into this trap of it has its own name. It's called a swamp, right? I'd like to quote Sean Martin from Cambridge Semantics here. We see customers creating big data graveyards, dumping everything into HDFS and hoping to do something with it down the road, but then they just lose track of what's there. I mean, you just put in data and then you just forget about it. And why do people forget about things, generally speaking? People forget about things when they're boring, when they're not interesting, when it's not really useful. There's nothing I can do with it right now. There's nothing in this that can help me with this deadline I have or this project I have. I mean, we are human, right? I mean, it's in our nature to forget because our memory is limited and we just don't want to have to bother with it. So, and this is maybe going back to the origin of, I'd like to quote PwC here. The main challenge is not creating a data lake, but taking advantage of the opportunities it presents. A means of creating, enriching, and managing semantic metadata incrementally is essential. So if you don't pay attention to how the data in your lake is continuously evolving, if you don't spend effort and conscious effort on making this data better all the time, you will end up with a swamp. When the data is in no man's land, nobody owns the data, nobody is responsible for it. It never gets any attention that it deserves. And there is an approach which I saw in practice, and I think might be an interesting solution to that. So it's actually about thinking in terms of organization functions. So if you look at your organization and you see what different parts of your organization are there, and what data do these parts use, and who is the actual owner of this data. So for example, this is not the exact real design, by the way, but if you have, news as part of your organization, you're bringing in all this news from all over the world, and you have this graph which you're building, which you're working on that. It makes sense to have more than one lake. It makes sense to have clear ownership of data. It makes sense that there is a team which it has one job in the world. They wake up in the morning, they only have one job to do, which is go focus on the news, or go focus on the graph, or go focus on the insights which links the graph with the news. So by having very clear ownership, you allow people to focus. You allow people to spend time on what matters, which is enriching and managing the semantics of the data. Now, remember not to fall into the trap of, okay, maybe we should just have more warehouses, or maybe we should just, if you scope down your lakes, you could potentially walk into a trap of creating a warehouse. But remember that this is an environment for people to do machine learning, for people to do analytics. It's an environment for people to develop. So once again, warehouses are not really suited here. And you can also say, okay, but maybe we should just, instead of these lakes, have a lot of pipelines. Replace these, graph and news lakes by pipelines. But once again, you have the same problem, because you have a problem just as like all the companies which I talked about in the beginning, because you can think of this as it's a small part or a small startup in your organization. So you still have data from several sources. You still care about data provenance and data governance. You still want to do machine learning, and you still want scalability. So, and what's the best answer or the best platform which we know today that does that? It's a lake. So, and whether you do this in a physical separation or just a logical separation on one physical lake is really a detail of implementation. But just remember that discipline will get you far, but having the right structure will get you a lot further. Now, the second part I want to talk about enrichments and how we can do this a little bit more effectively or efficiently than we do today. So, Facebook is really one of the largest mass producer of enrichments or machine learning models in modern day world. And if you look at how they do that, they actually published a paper explaining how they produce all these models. And they have an internal system which is really interesting called FB Learner Flow. And in this system, you have this luxury of picking any algorithm that anyone else in the company has ever built, putting it in sequence, creating a workflow with every other algorithm everyone has created, and then picking a data set that anyone has ever created at Facebook, and just clicking a button, let it run, and then if it comes out good, you just click another button and it gets deployed to production. I mean, it's like riding in a Bugatti while all of us are on scooters, right? So it's but we don't have to despair. There is a next best thing which we can do. I mean, which is we can draw some parallels from this architecture, and the answer to that is very simple. Just build a library. Make sure you can reuse your work. Don't do something twice. So first thing, please, pretty please, I know everyone loves their Jupyter notebooks, but please don't make your deliverable a Jupyter notebook, and don't make your deliverable a machine learning model. Make your deliverable a training pipeline for your sake and for everyone's sake. People go on vacation, parental leave, they get sick, they change companies. You don't want to go hunting somebody else's Jupyter notebook, and at the same time, you want, even for yourself, to be able to retrain your data again and again once you have new data, once you have new signals, once you have new annotations, once you have feedback. You want to be able to reuse it. Okay, so that's easier said than done. So how can we do that? Okay, so every machine learning pipeline has three, maybe, I mean, definitely maybe more components, but in a broad sense, it has a preprocessor, it has a feature extractor, and it has some kind of classifier or regressor, right? And the idea is to take advantage of basically generics. So wrap around your components in three types of generics: an enricher, a processor, and a container. And what an enricher is meant to be is to be like the closest thing to your machine learning model as possible, or to your preprocessor or feature extractor. So let's assume we have for simplicity, let's assume we have one machine learning model, which is, it's an explicit text detector that just has a list of, it's a very stupid detector, it just has a list of bad words, and it filters out documents using those words. Create an enricher, which has three functions: an init, enrich, and destroy. So just initialize, enrich, destroy. That's it. That's the interface you want to stick with. Don't make it complicated. Don't overdo it. And make it so that it takes in the most primitive form, which is a string, and produces the most primitive form, which is a Boolean, right? Abstract away all the TensorFlow, scikit, whatever you're using. Abstract away all that within the enrich function, right? And just have a string come in and a Boolean come out. Now, the next thing is you want to use that with real data. So you want to have some kind of data model, right? Because maybe you work with music, or maybe you work with news, or maybe you work with comments and reviews on a website, right? It doesn't matter. Your processor will have a very, very similar interface: an init, a process, and a destroy. And the process function will just take in your document model, whatever it is, a track, for example. And you know, the document model has a lot of stuff: a name, a title, a bunch of artists, whatever. And it also has a lyric field. And then it extracts that lyric field, which is a string, puts it through the enricher, and then gets out the Boolean, takes it, and puts it into the document model. And this way, your enricher is just reusable across your entire company. Anyone who wants to do any kind of explicit detection can just reuse that enricher now. And when you start doing this in practice, and you do this for your feature extractor, you will be able to mix and match your feature extractors together with different classifiers. You'll be able to mix and match, bring in a lot more features, and just bundle them together. And this way, you can create a lot more complex pipelines by just reusing components that everyone else in your organization has ever built. And finally, the container, because this interface is so simple, init, process, destroy, you can just wrap any processor in whatever reusable pattern of deployment that you have. So for example, I mean, if you're using Python, you could literally create a for loop and just deploy every single processor that you have in an API. Because it's duck typing, right? So you can just have a for loop that creates endpoints based on the names of the processor, calls init, and takes whatever comes in, puts it to the processor, and then calls destroy when the processor is done. You can literally have all your processors in a Docker image and just serve that as an API. Or if you want to, if you have a common pattern with Spark or with, data flow, if you're on GCP, where you read from PubSub or from some file storage, you can just make that into a pattern and make it take any processor. So make use of that generic pattern. Right. Right, and for the sake of brevity, this was just to point out that training machine learning is an application, so it happens on data that is imported from the lake. And when you deploy it, there's something called, there's this concept, very nice concept of lakes which are staged. So you can actually deploy enrichers within your lake. It's a very nice concept, but I don't have time to cover it. But I recommend you really have a look at it. Finally, don't discriminate against open source datasets or research datasets. Chances are, if you're a music company, the datasets you use is music, right? So just if one person in your organization puts in the effort to import that data into the lake, and then it gets enriched with all of your enrichers that you have created in the lake and that are working continuously there, then that data is continuously available to you with all of its enrichments, and you can experiment on it so much more. And as we know, the more you experiment, the more you can find better models, the more you are able to produce more insights and so on. And the same with human annotation. All annotation is created equal, so don't be racist. And the takeaways here are, it's the usefulness of the data that counts. It's the usefulness of the data that matters. That was the whole point of creating lakes. Make sure that your components are reusable all the way, and think in terms of your organization functions and what that data means to different parts of your organization. Finally, I would like to reiterate this quote: the main challenge is not creating a data lake, but taking advantage of the opportunities it presents. I hope you found this useful. That's all I have. Thank you for listening.